All right, this lesson is going to be over factoring, and we've already did a lesson on factoring. In fact, we probably spent 3 or 4 days on it. Make sure that you've already watched the previous lesson, which was the ax squared plus bx lesson. You could find that in the notes. It's the one right before this. Today, we're going to learn how to factor x squared plus bx plus c. For example, we're going to learn how to factor x squared plus 3x plus 1. Okay? Let's say plus 2. How do I factor that? That's the question. All right? Now, what does factoring mean? Well, when I have 3 pieces like this, it means I'm going to multiply a parentheses times a parentheses. All right? Now, let's just say this is equal to 0, and I asked you to solve it. Well, what most of you would do is you would do this. You would subtract 2 from both sides, and you'd get x squared plus 3x equals negative 2. And then you would try to somehow add these x's together, but you can't. So you're stuck. There's nothing that you can do. What your brain has to do is you have to use that 0 trick. Remember that 0 trick that I taught you on the last lesson, which is if I can break this up into 2 things being multiplied, then I know that one of them has to be equal to 0. Okay? In this case, the 2 things are x plus 1 and x plus 2. You can check that by doing the Punnett square for that. X plus 1 and x plus 2. X times x is x squared. 1 times x is x, 2x, and 2. You get x squared plus 3x plus 2, which is exactly what this says. So, if I could somehow find a way to break it up into those 2 things, then I know that one of these has to be equal to 0. Either this is equal to 0 or this is equal to 0, because that's the only way you can multiply 2 parentheses to get 0. One of them has to be 0. So remember what we did. We broke them off into 2 problems. So either x plus 1 is equal to 0 or x plus 2 is equal to 0. You solve them, you get negative 1. Subtract 1. Well, I'm just going to give you the answer. X is either negative 1 or x is equal negative 2. If you put a negative 1 into this equation, you get 0. If you put a negative 2 in this equation, you get 0. All right? So the whole point of this lesson is this. I need to find out some method to turn this equation into 2 things being multiplied. Okay? And that's what this entire lesson is about. How do I turn this into this? Now, there are lots and lots of ways to do that. And about 6 years ago, I came up with this lesson and started teaching it to my kids. The second I started teaching how to factor this way, my students stopped having trouble with it. In fact, my students were doing better than any other students in the school, just simply by me teaching them the method that I'm about to teach you here. So if you go home with your parents and start trying to learn how to factor with your parents, they're not going to do it the same way because this is my own method. All right? But I will tell you that it's a quick and easy way to learn how to factor. All right? So here's what you're going to do. If you want to factor this, what you need to do is you need to make a table. Okay? So you're going to make this table, and it's going to have 3 pieces. Okay? In the first piece, this goes here. So this goes here, 1x squared. Put the 1 there, okay? Trust me. All right. Now, question. Of these 2 pieces, how was this made? How was this 11x made? This 11x was made, if you think about the Punnett square for a minute, if you think about our Punnett square, if you think about how this Punnett square was made, the 11x was created by adding these 2 pieces, right? So if you think about it, there's 2 things up here, there's 2 things here, and this diagonal was created there to make the 11x. How was the 18 made? Well, it was made in this box right here when you multiplied some number times some number. Of the 2, it's easier to figure out what this number was because you know that it has to just be 2 numbers being multiplied to make 18. To find out what these two pieces were, there's millions of things that can add to 11x. 1 in 10, negative 1 in positive 12. There's millions and millions of things that can make 11 when you add them. But there's very few things that can multiply to 18. Okay? And that's what we're going to focus in on. So be careful with this. I'm going to write the 1x there. I'm going to write this here. And how's the 18 created? I want a product of 18. And then how was this created? It's created by a sum, right? I want a sum of 11. You could put 11x if you want. I'm just going to put 11, okay? So this goes here, the ending goes here, and the sum goes there, okay? What this is going to do is this is going to break this up into this box is going to be this, the product is going to be this, and this is going to help me to know what those two pieces were, okay? That's what this table is going to do. All right, so here's what you do. You look at the first column, you say, what times what makes 1? What two numbers can I multiply together to get 1? Well, it's 1 and 1. Here's the cool thing. You don't have to consider negative numbers, only positive numbers for this, okay? So 1 times 1. Agreed? Now, what are some things that multiply to 18? So let's start listing them. Well, I could have 1 and 18. I could have 2 and 9. I could have 3 and 6. I could have, let's see, 3, 4, 5, 6, and 3. I could have 9 and 2, or 18 and 1, right? Now, these last 3 and 6 and 6 and 3 are actually the same thing, so I can actually don't even need to look at those, okay? All right, so here's what I'm going to do now. I need to take the first thing from this and the first thing from this and multiply them. So I'm going to multiply this times this. 1 times 1, and I'm going to multiply the second thing from this and the second thing from that. So 1 times 1 is 1, and 1 times 18 is 18. And then I'm going to add those together. 1 times 1 is 1, and 1 times 18 is 18. 1 plus 18 is 19. Well, that's not my answer because I'm trying to find out which one gives me 11. So it's not this one. So I'm done with that one. I go to the next one. Well, it could be 1 and 1 and 2 and 9, right? So let's try this. 1 times 2 is 2. 1 times 9 is 9. 2 plus 9, 1 times 2 is 2. 1 times 9 is 9. And 2 plus 9 is 11. I found it. That's the key. When this number matches with this number, it tells me that the math that I just did there is the key to my problem. Now, I'm running out of room here, so I'm going to make these bigger just so I can see them, okay? So just give me a second here. Right? 1 times 2 is 2, 1 times 9 is 9, and 2 plus 9 is 11. I found it, right? I'm going to make it bigger, so 11. All right. Now here's the key. I told you a minute ago, you multiply the first thing times the first thing and the second thing times the second thing. You add them together and you're trying to look for this number, right? Well, I found it. Now here is the key. I cannot stress to this enough to you right now. When you find the one that works, you need to then put your x's back in there, okay? Because how did I make 1x squared? It wasn't 1 times 1, it was 1x times 1x, right? When I find the one that works, this is what you need to do. The middle numbers come together and the end numbers come together. Please, please, please do that. All right? The middle numbers come together and the end numbers come together. I do all that because now my two pieces are, what's the middle part? 1x and 2, which is x plus 2. And my ends come together, so x and 9, x plus 9. That's my two pieces. To factor that, it turns into this. Now you may be thinking, oh my gosh, that just took us 10 minutes. There's no way I can do that. You're going to get very fast at this really quickly. So just do a bunch of these. We're going to do a bunch of these so you can get the pattern down. But that's what you're trying to do. I just broken it up into x plus 2 times x plus 9. Now, when you do all that math, you do need to check it at the end. So you make a Punnett square. And you check that. You check to see that if x plus 2 times x plus 9 does actually give me what I started with. X times x is x squared. X times 2 is 2x. 9 times x is 9x. 9 times 2 is 18. I get x squared plus 11x plus 12. X squared plus 11x plus, not 12. How about 18 there, genius? 9 times 2 is 18, not 12. So I get x squared plus 11x plus 18. There's my answer. This is my answer. Okay? Let's try another one. All right, make my table first, right? And I'm actually going to try to give myself some more room this time. So make my table. Okay, remember what goes here. What goes here? This goes here, so 1a squared goes here. What goes here? The last thing. How was the 10 created? It was created by multiplying two numbers, so I want a product of 10. How was this number created? That number was created by the diagonal of the Punnett square, and you're going to add two things. So it was created by a sum. So I want a sum of -7. Got it? All right. So here's what I'm going to do. I just start listing things that work. What times what makes 1? Well, how about 1 and 1? What times what makes 10? Well, it could be 1 and 10. It could be 2 and 5. Anything else? Well, it could be 10 and 1 or 5 and 2, but you're going to get the same answer. But I'm actually not done because there's actually some other numbers that work. Because let's go through this first one real quick. If I do, let me check these two real quick. Remember what I do? I multiply the first thing times the first thing and the second thing times the second thing, right? I'm going to do that in red. So I do the first times the first. I do the first times the first and the second times the second. So I do the first times the first and the second times the second. 1 times 1 is 1. 1 times 10 is 10. 1 plus 10 is 11. Well, I'm way off because I want a sum that's negative. Well, that's not going to work, right? Try it with the next one. 1 times 2 is 2. 1 times 5 is 5. The 2 plus the 5 makes 7. Well, that's negative and that's positive. I'm closer, but it's not negative. So I'm in trouble. So now what I need to do is figure out what am I missing, because I tried everything that I could think of. But I actually didn't, because what I need to do now is understand that there's other numbers that multiply to 10. -1 -1 and -10 work. Doesn't -1 times -10 make 10? Yes. Also, -2 and -5 are going to work. Now this one, when I do the math for this, I'm actually just going to get -11. But when I do this one, this is the one I'm going to spend time on. 1 times -2 is -2. 1 times 5 is -5. And -2 plus -5 is -7. That's the one that works. That's the sum that I wanted, which tells me that this stuff right here is the key to my problem. So what do? I put my x's back in, right? Because it's actually 1x times 1x. Then remember, I put the middles. I multiplied the first times the first and the second times the second, but when I write my answer, the middle comes together and the ends come together. So what's my answer? Well, it's x minus 2 and x minus 5.
check it with the Punnett square. Take a 2 seconds to check it with the Punnett square. X minus 2, x minus 5. This is x squared minus 2x minus 5x plus 10. X squared, or a squared in this case. Actually, these should have been a's the whole time, right? Those are a's. X squared times x squared is x squared, or x times x is x squared. Negative 2x plus negative 5x is negative 7, yeah? And that makes 10, that makes 10. That's my answer. Got it? All right. Now, real quick, what I wanted you to talk about is if you're smart when you're doing these problems, you don't have to write a whole bunch of things. In a day or two, you're going to get good enough at this where you're just going to pretty much always just write one, maybe two, before you get the right answer. You'll be flying through these really soon, okay? So let's do the next problem. All right, make my table, right? I got a lot of room this time, so make my table. All right, I get 1y squared. I get a product of what? Can you remember? Product of negative 15. And I want a sum of 2, right? Well, remember, it's going to have to be 1 and 1. Every problem tonight is going to be 1 and 1. Now, this is going to be the first example where I want you to start being smart about what you're doing. Go ahead and put your pencil down for a minute and just think about this. I know that the product's going to be negative. So what does that tell me about the two numbers? Well, it tells me one's going to be positive and one's going to be negative, right? What am I going to do with those two answers? Well, at some point, I'm going to add them together, right? So I now know that one of the numbers is positive and one of them's negative. But check this out. I also know that the sum is positive. That means when I add these two numbers together, I get a positive number. So what does that tell me about the positive number and the negative number that I'm multiplying? If you think about it for a minute, it tells you that since I'm going to multiply, I know I'm going to multiply two numbers to get a negative, so it's one positive, one negative. But it also tells me that the positive number has to have more chips. Or as I like to say, it's bigger, yeah? Because when I add these together, if I have more positives and negatives, I'm going to have leftover positives. So right now, I now know that it's one positive number and one negative number, and I know the positive number is bigger. So now, there's only two things it can be. It can either be 15 times negative 1, because a positive and negative, and the positive is bigger than negative, or it can also be 5 times negative 3. Now, how did I choose those two numbers? One more time. I knew that it had to be a negative number, which means one positive, one negative, but I also knew that when I added them, it has to be positive, which tells me the positive has to be bigger than the negative. So then what do? I multiply the first times the first, the second times the second. 1 times 15 is 15. 1 times negative 1 is negative 1. 15 plus a negative 1 is 14. Way too big, right? Try the next one. 1 times 5 is 5. 1 times negative 3 is negative 3. 5 plus a negative 3 is 2. Found it. There's my answer. Remember what I do now. Once I find the one that works, I put my y's back, because they're y's this time, right? And then what comes together? The middle comes together, and the ends come together. Okay? In a couple days, I'll explain to you why it's the middles and the ends, but right now you just need to do it. Okay? So what are my two pieces? So one of my pieces is y plus 5. What's my other piece? Y minus 3. All right? Check it with a Punnett square. Y plus 5. Y minus 3. Y times y is y squared. 5 times y is 5y. Negative 3 times y is negative 3y. Negative 3 times 5 is negative 15. Check this out real quick. This Punnett square is everything that I have here, and I'll prove it to you. The 1y times the 1y is the y squared. This is this. Where does the 5 and the negative 3 come in? It's the diagonal. Where does the negative 15 come in? The negative 15 comes in, it's the product, right? All this stuff is here. Everything is here. The 15, there's the 15, there's the negative 2, or there's the positive 2, and there's the y squared. It's all in the Punnett square. So what's my answer? This is my answer. That's the factors. Okay? Okay, by now you're probably getting to the point where you're starting to pick up the rhythm of these problems, okay? That's my hope at least. I'm going to do a few more, but if you'd like at this point, you might want to try this one yourself and then go ahead and pause the video, try this one yourself, and see if you get the answer that I get. All right, so go ahead and pause the video if you want to try that yourself. First thing I do is make my table, right? I know this is 1w squared. This is a product of negative 16, which tells me one's positive, one's negative. And then I want a sum of 6. So let's see if we can get smart this time. I want a product that's negative, so I know there's one positive number, one negative number. And when I add those two numbers together, the answer is positive. So what does that tell me? It tells me that my positive number has to be bigger than my negative number. My positive is bigger than my negative. So can you think of two numbers that you can multiply together where the positive is bigger than the negative? Well, there's probably two that come to mind. Either negative 8 times 2, and actually I can't think of any other. Oh, not negative 8 times 2. What did I just say? But you know what? It's already written, so let's try it. Watch what happens if I use negative 8 times 2. 1 times negative 8 is negative 8. 1 times 2 is 2. Negative 8 plus 2 is negative 6. I just got the opposite of my answer, which then tells me that the correct answer should have had the negative, the 8 should have been positive, and the 2 should have been negative. And I said that at the beginning. I said that the positive had to be bigger than the negative. So 1 times 8 is 8. 1 times negative 2 is negative 2. 8 plus negative 2 is negative 6. Found it, right? So once I found the one that's right, put my w's back, right? And do you remember now what goes together? Well, the middle comes together and the ends come together. So what do I get? I get w plus 8, and I get w minus 2. And then you would check it with a Punnett square. I'm not going to spend time right now because this video is getting long, but you would check this with the Punnett square to make sure that you get this. Okay? All right. Example 5. What's different about example 5? Look at example 4 and look at example 5. What's the difference? Well, the difference this time is 1, Mr. Gillespie's a dingbat, and this should have been a B and not an N. So pretend that's a B. Now, what else is different? Well, the big thing that's different is this one is equal to something. I can actually solve this problem. So let's look at this problem real quick. I need to solve for B. What does B equal? Can you solve that? Right now, unless you're in your mind right now, unless you're thinking about factoring, you don't have a way to solve this. And that's exactly what we're going to do. What we need to do is do what we've been doing in every problem before this, which is break it up into two things being multiplied first. Okay, so let's do that. Let's make our table. Okay, what goes here? 1b squared. What goes here? Product of what? Product of 8. What goes here? Sum of negative 6. Okay, so this has to be 1 and 1. Now let's see how good we are. Okay, I have to make a positive product, right? What does that tell me? Well, it's either two positive numbers or two negative numbers. But the sum's negative, so what does that tell me? Well, if the product's positive but the sum's negative, it tells me that it has to be two negative numbers. What two negative numbers? Well, it could be -1 and -8, but that's going to be too big. How about -2 and -4? Let's try that. 1 times -2 is -2. 1 times -4 is -4. -2 plus -4 is -6. Got it on the first try because we're awesome. Then, once you find the one that works, what goes together? Well, you put the b's back, right? And what goes together? The middle and the ends. So what are my two factors? b minus 2 and b minus 4. Now this time it's actually equal to 0. Now if you go back to every one of those lessons that I've been doing in the last couple days, when two things are being multiplied that equal to 0, what does that tell you? It tells you that either this is 0 or this is 0. One of those two pieces is 0. Okay? Which one? Well, actually both of them. So b minus 2 has to be equal to 0, or b minus 4 has to be equal to 0. One last time, why 0? Why do they each equal to 0? Because if I'm multiplying two things and they equal 0, one of them has to be 0. Okay? Solve this one. Add 2 to both sides. I get b equals 2. Add 4 to both sides. I get b is equal to 4. So my answer is b is equal to 2 and 4. You would check this with the Punnett square. You could also put these numbers into this equation to see if they work. Let's do that real quick. Let's try the 2. Put the 2 in. 2 squared is 4, minus 6 times 2 is 12. 4 minus 12 is -8, and -8 plus 8 does make 0. If you do it with the 4, it'll also work. Okay? But that's my answers. Two answers, and it's both of them. And that says and. Okay? All right. We've got 3 more problems here. All right, so let's try these. For sure by now, on example 6, these problems are problems that we're probably doing either the second or the third day of your notes. So we probably would have stopped after example 4 on the first day, and we might have gotten to example 5 and 6 on the second, possibly the third day. So check with me to see where we're at, okay? Let's do this problem. Before I can solve this problem, I need to make sure it's equal to 0. And I'm going to tell you right now, when in doubt, make it equal to 0. So how do I make this equation equal to 0? Well, the quickest way to do that is to add 2y to both sides, right? And remember, I want it in order, so y squared plus 2y minus 15 equals 0. Yeah? Then what do? Well, I need to factor it, right? I need to break it up into two things being multiplied, right? So how do I do that? Well, I make good old Mr. Table. What goes here? 1y squared. What goes here? Product of -15. What goes here? Sum of 2. Be careful. It's not what that says, it's what this says. So it's a positive 2. Yeah? All right, let's do this. 1 and 1. Now, be careful here. I have a product that's negative. What's that mean? 1 negative, 1 positive, right? Also, because the sum is positive, it tells me the negative number is smaller than the positive number. I have more positive numbers than negative numbers. So I need to multiply two numbers, one positive and one negative, and I have more positives. Well, hopefully the first thing that comes to mind is -3 and +5. Let's see if those work. 1 times -3 is -3. 1 times 5 is 5. -3 plus 5 is 2. We got it on the first try. If that didn't work, I'd have to try other things, okay? Then Once I get the one that works, what goes together? The middles and the ends, and don't forget your variables, which were y's in this case. Yeah? So what are my two factors? Y minus 3 and y plus 5. Then what do? Well, now that I've broken up into two things being multiplied, then one of those things has to be equal to 0. So either y minus 3 is equal to 0, or y plus 5 is equal to 0. So either y is equal to 3, or y is equal to negative 5. So what are my answers? Y equals 3 and negative 5. Okay? Example 7. All right. When I say g of x is equal to x squared minus 8x plus 12, here's what you're going to do. You're going to basically say, if you have a g of x, which is a function, what you want to do 98% of the time is g of x is the same as y, right? What you want to do is make y equal 0. So basically what you're going to do is take the g of x, it's the same as y, and you're going to make y equal 0, and you're going to factor it and solve it if you can. That's what you're going to do. Real simple, right? Don't ask me about this one in class tomorrow, because if you paid attention to these notes, all you have to do here is that's the same as y, make it equal to 0, and do the exact same thing we've done in every other problem. So let's do that. You should probably get pretty quick at your tables now. So I'm going to go a little bit faster. In fact, this would be a good problem to just stop the video and try it yourself and see if you get my answer. All right, so product of 12, sum of negative 8. All right, 1 and 1, right? I need a product that's positive, but a sum that's negative. Ooh, okay, one negative and another negative. All right, what can I try? Well, I can try 4 and 3. Let's try 4 and 3. 1 times negative 4 is negative 4. 1 times negative 3 is negative 3. Negative 4 plus negative 3 is negative 7. So close, but not the right answer. So what else could I try? Some students right there will say, well, Mr. Gillespie, I tried everything and nothing works. Well, you didn't try everything. Did you try negative 2 and negative 6? Because watch this. 1 times negative 2 is negative 2. 1 times negative 6 is negative 6. Negative 2 plus negative 6 is negative 8. I just found it. So put my x's back in. What goes together? The middles and the ends for the 7th time. So what is this? 0 equals x minus 2 times x minus 6. So x minus 2 equals 0, or x minus 6 equals 0. So x is equal to 2 and to 6. And that is my answer. Okay? All right. Last example, example 8. These notes have been going on for 30 minutes. All right, first thing you need to do is, first of all, this is what you can't do. You can't say a plus 6 is equal to 8 and a is equal to, negative 8. You can't break it off into two problems. That only works when this is 0. If this was a 0, you could break it off into two problems. Unfortunately, it's not a 0. So this is what you're going to have to do. You're going to have to first distribute that a, and you get a squared plus 6a equals negative 8, 6a. Then you need to make it equal to 0 by bringing the 8 over, and you get a squared plus 6a plus 8 equals 0. That's an a. All right? Stop the video. Try that problem yourself. This is a real easy one. I'm going to keep going on it. I want 1a squared. Next lesson, this is no longer going to be a 1. I want a product of 8, and I want a sum of 6. Well, that's easy. 1 and 1. I want a product, a sum that's positive, so that's two positive numbers. the first thing most people would try is 2 and 4. 1 times 2 is 2, 1 times 4 is 4, 2 plus 4 is 6. It works. Put my a's back. What goes together? The middles and the ends. So what are my factors? A plus 2 and a plus 4 equals 0. Break it off into two problems. And I get a is equal to -2 and -4. And if you got that right, you're well on your way to understanding factoring. That was a 35-minute lesson, but we would probably spend 3 days in class going through these problems. Take your time on these, really take your time, use the table, and I guarantee you within 3 or 4 days you'll be flying through these. Good luck.